to just graph this on your paper, it can be graphed as simple as this. So I do want you to have this drawing on your paper for this example here. I do want you to have this drawing here for this example. Once you have that drawing there, we're going to go ahead and do this one. As a class, the very first one, it wants you to tell them if this graph here is continuous or discrete. Continuous or discrete, our first step would be to describe what type of graph this is. Looking at it here, going back to the notes we just took, point number 2, is our domain here continuous or discrete? Shout it out. Continuous. Again, the tip was, if I can draw this without picking up my pencil, I know it is. I know it's what? Say it again. What is this? Continuous. We have it here, continuous. Go ahead and write that in. Continuous. Now we have to actually explain why it's continuous. And I want you to use the actual definition we wrote in key point number 2. I would say something like this. It is continuous because graph includes, because the graph includes all of the numbers, all numbers in the we can say domain or in the interval. So this is how I want you to do these. The very first one, again, we can say if it's continuous or discrete, and then we explain it using our key points, using the information we have learned. For the second one here, let's do it again as a class. On your papers, you do not have to write the whole thing. I just want you to write a concise version of this. It can be as simple as drawing your graph and then placing 3 dots like that, as follows. You can number this one number 2, number 1 there, number 2 here. And for this one, using that same tip again, notice that when I draw this, I have to pick up my pencil every single time. This one. What do I say? Shout it out. Is this continuous or discrete?
Discrete.
Discrete. Perfect. Discrete. Now let's use our information from our key point to describe why it is discrete. You want to give it a shot? Okay, tell me.
Because there are only certain numbers can be there.
Perfect. Because only certain numbers can be in that interval. Perfect. Because only certain numbers can be in that interval. That is a perfect explanation. And if you want to be specific, if we look at our x-axis, we can say what those certain numbers are, right? Notice our first dot here is at 4, second dot at 8, last dot at 12. We can say exactly what those numbers are. If I wanted now to explain, to actually write the set notation for this here on our x-axis, how can I go ahead and do that? Looking back to our key point number 2, the example I wrote under discrete domain, go ahead and look at that. Under discrete domain, where it says set notation, how was it that I described the notation for that domain? Notice we start again. I'll start it off. We said domain.
We didn't connect them.
We didn't connect it, so are we using set notation or an equality notation, Omar?
Inequality. We set notation, yeah.
Why set?
Because.
Yes, be more specific.
Because it consists of only certain numbers.
Only certain numbers, and we use set notation. Now, again, if I do want to actually represent the set notation, guide me from here. What should I do next?
Ooh.
And you get more hands. This is it. Just going off of our notes, how can we actually write the set notation of this here. And we're using these values here. Yes, Yarissa? Just write the numbers. Yes, we got you. Curly braces, perfect. And now, my 4, parentheses or comma,
Eight, and then comma, and then 12. And then your curly
and then I close it. And I have successfully wrote the domain of this discrete function or graph there. Alright, now that we've done 2 as a class, a continuous and discrete, I want you to work on these bottom 2 by yourself, silently. I'm going to give you the next 2 minutes to work on these. Again, I want you to tell me if they are discrete or continuous, and also then explain using the information we learned from our key point number 2. Go ahead and begin. We'll meet up at 10:22. Remember, you don't have to write or draw the graph exactly as it is. As long as you have an idea of what type of graph it is, you're able to then work with what you have here. Nicely done. We've seen really, really good work. Those of you that have done early, I'm going to challenge you to write either the set notation or the interval notation for those graphs there. How many of you still need a few more seconds to finish up? Raise your hand. All right, I'm going to give you about 30 more seconds. Go ahead and finish up. Question? If you're done early, I'm going to challenge you to do it. Yes. All right. Pencils down. Let me get eyes on the board. You can stop working now. And wait for 100%. Eyes on the board. Thank you. All right. Let's go over these as a class. For this one here, number 3. I'm just going to label them really quickly. Number 4. Number 3. What did you say they said for this one? Continuous or discrete? Continuous. Perfect. This one was continuous. Can you tell me why, specifically, using the definition that we learned? It has numbers that are, say it again, that are all intervals. Can you phrase that a little bit differently? Going back to the definition that we learned, continuous domain. The words you used were correct. I just want you to rephrase it somewhere differently. Yes, it has all numbers that are in the interval. In the interval. So using the definition, the values are, the set consists of all numbers that are in that interval. Yes. Consists of all numbers in that interval. The last one over here, Bridget, what did you say about this one? Continuous or discrete? Discrete, perfect. Discrete. And tell me why is discrete.
Because only certain numbers can be in the interval.
Can you repeat that again?
Only certain numbers can be in the interval.
Only certain numbers can be in that interval. Perfect. Only certain numbers be in that. And again, before I move on, I do want us to practice again using set notation to describe what is going on in this equation here. Omar, you want to give it a shot?
Yeah, I got domain equals
All right, slow down for me. Step by step. Domain.
DOMAIN.
Not that slow, but go.
Equals the curly bracket.
Equals.
I mean,
Where's that word we're using again?
colon.
The colon. Go ahead and fix that as well. Colon. That makes you lose points though.
And then the curly bracket.
We're talking about our x values here.
Yes. And then -3.
-3.
Yes. Comma. -1.
-1.
Comma. 1.
1.
Comma. -3. Not negative. 3.
Positive 3?
Yes, positive 3. And then another bracket.
And then we close it up. Perfect. Well done, Omar. There we go. That's how we represent set notation for this problem here. Alrighty. Now I'm going to go ahead and switch to the next slide. Question?
Yes, like, is there a certain side you have to start on?
What do you mean
Like,
side?
You know, like when you're doing the listing them out, like, you have to start from the left or?
Yes, that's a great question. So she asked if, when we're doing set notation, is there a certain side that we start on? We want to start on the left side. I'm actually going to go ahead, go to the next slide, because that's going to allow us to see where we're going to start. But yes, we start with the most negative number. Negative 3 was our most negative number here on the left, on the far left, and we moved over to the right. Here as well, we started from our left, and we move on to our right. It's like when we're writing, we go from left to right. Same thing when we're describing our set notation. All right, let me go ahead and erase this so we can move on. These were more examples there, but at the same time, we're going to go ahead and move on. For this key point, again, I want you to write this somewhere neatly where you have enough space, because I'm going to write a few notes on this after we have this down. Question? Go ahead. Yes. If you need another paper, I'm going to come around and give you some more. Another sheet. Make sure we are writing this key point on our paper. Make sure you at least have those definitions here for domain and range. And then this here is answering sort of maintenance question. We're starting, we always look at the beginning on the far left, and we always end on the right of our equation or whatever we're dealing with for that one. Make sure we're writing, Jose. Yes. Can we move up? The bottom part? Yes. I do want you also to be writing the part at the bottom where we talk about the end marking and the notation we use. These are very, very important things that I do want you to have down on your notes. Yeah, this, you don't have to write this. I do want you to write the definitions and this sort of stuff down as well. You don't have to write that sentence down. Just go ahead and skip down to the actual part and marking the notation. Raise your hand if you still need about 1 more minute to write down this bottom part here. All right. Go ahead, take 1 more minute. It doesn't have to be perfect. It doesn't have to be something that you can refer back to when you are looking at your notes again. All right, let's go ahead and start writing. You can put your pencils down, and I do want to have all eyes up here. Let me get all eyes up here. You can start writing now. We'll have more time in a little bit, but I do want us to talk about this. This here, down here first, this is stuff we already know. On the number line, when was it that we used a closed circle or a closed dot here, Omar?
Oh, when it's equal to.
When we had an equal to sign here. So this is why, on our notation, we use a closed circle on our head marking whenever we use an or equal to sign here. Down here, we're using just the less than symbol, no or equal to, so guess what we use? Open circle. Perfect. Stuff you already know. Going back to our definitions of domain and range, this is very key stuff. This is stuff that you're going to be seeing in all of your math classes from now on, and I suggest we get used to this right now. Domain are the possible input values of a function. I want you to think back to yesterday. Which variable described our input? Say it again. X. Our input values were our X. So now on your papers, I want you to go ahead. Above input, write our variable X. We are talking about X. This is all the possible input values in a function. Another way to read this, all the past possible X values in a function. So whenever we talk about domain, we are talking about possible X values. With range, it's the opposite. It's all the past possible output values. Shout it out. Which variable am I using to represent?
Y.
Y. Go ahead and write this on your paper as well. We use our variable y to represent the possible output values in a function. So just so you have a little bit more notes, I do want you to write following domain when I'm talking about the domain, I'm going to refer to my x-axis on the graph. X-axis. So if I have my graph, if I'm looking at my x-axis, show me with your hand. Is this my horizontal axis or my vertical axis? Show me with your hands.
Horizontal.
Horizontal axis here. I'm looking at my x-axis, which is horizontal. So domain. When we talk about domain, the possible x values in a function, we're going to refer back to our x-axis. And this is when we look at it from left to right. We look at this from left to right, starting with our most negative number all the way to our most positive number. So answering your question, we always start at the far left and we move over to our right. This is why I wanted you to write this down. The second part of this is our range. If we're looking at the x-axis, we're talking about the domain. My range, Jose, which axis would I be looking at? The y-axis, perfect. I want you to have this written down on your paper as well. Y-axis. And for range, this might get a little bit more tricky. Range, since we are looking at our y-axis, we look at this from low to high, from our bottom to high. Again, because